Well, welcome back to another exciting probability topic. Today we're going to focus on calculating conditional probabilities. Let's see, so again, as far as copying things down go, let's just get a few things I highlight in here. Suppose the following information is known. Here's what we need to copy down. 40% of the students are involved in one or more of the after-school athletic programs. It is also known that 58% of the students are female. The students decide to construct a hypothetical 1,000 two-way table. So make sure you pause it and let's get this table copied down as well. Now you don't need to label them cell 1, cell 2, etc., but just get this table down. When you're ready, turn it back on. All right, so question 1. What cell in table 1 represents a hypothetical group of 1,000 students? Where would you put this 1,000? Hopefully, you have enough confidence from yesterday to say that your total would be 1,000. And I'm thinking, and I hope you agree, that would be cell 9. What cells in table 1 can be filled in based on the information known about the student population? So let's see, if we know that 40% of the students are involved in one or more of the activities, I would say I would go to, yes, students participate in athletic programs, and my total is 40%. So I'm saying cell 7. And then if I know 58% are female, I would say the total, so total column of females would be 58%, so that would get me cell 3. Question 3 says, now the athletic director indicates that 23.2% of the students are female and participate in athletics. What cell would that be? Okay, so I'm going to go to my female, so I'm someplace in this row, and I participate in after-school athletics, and I'm someplace in this row, so I would say those two meet at cell 1. Well, you've probably guessed it. What you need to now do is pause it and fill in this hypothetical two-way table. So remember, we know cell 7, 3, and 1. So pause it, see what you get. Well, I'm hoping your probabilities agree with mine. Again, to get this cell, 58% of 1,000, just move the decimal. I got 580. 40% would be 400 of 1,000. And the 23.2% got me this, and then I just figured out the missing pieces. So our first question, what is the probability a randomly selected student is male? So what is my event here? So I want the probability of the event over the probability of the sample. So the event that is happening is that a student is male. So if I take a look, my male students would be 420 over my sample would be all of my students. So out of 1,000. Next question. What is the probability that a randomly selected student participates in after-school activities? So again, the probability of the event over the probability of the sample space. So the event that is happening is that you participate in after-school activities. So I find my participate in after-school activities, and that's a total of 400 students out of my whole sample of 1,000. What is the probability a randomly selected male student participates in after-school athletic programs? So the event that is happening is that I participate in after-school programs out of just being male. So if I participate in an after-school program, I'm in this column, and I just want to be male. So I would say that would be 168 out of 400. So I participate in the after-school program, but I'm just male, so that's 168 out of 400. Okay, so now consider the following events. So we're going to have to take time and write these out, and we'll fill in some blanks here. So let A represent the event, a random student is female. Let not A represent the complement of A. So let's underline this word complement. We have to be familiar with this term. Complement just means, and you can put an arrow to it, not. So what does this mean? The complement represents the event a randomly selected student is not female. So if I want the complement of A, I'm basically saying the opposite. If A is a student is female, the complement would be the student is not female. Let B represent the event a randomly selected student participates in the after-school athletic program. Therefore, let not B represent the complement of B. So the complement of B represents the event a randomly selected student does not participate in the after-school athletics program. Let A or B be described as a union, denoted with the symbol U. Pretty straightforward, union when U. Represent a randomly selected student is female or participates in the after-school athletic program. So the big thing we have to get out of this, when you see the word or, we need to consider it as a union. Just put another note there. A lot of times they're going to say A union B. So in your head, you have to say A or B. Let A and B be described as an intersection, denoted with the symbol, kind of like an upside down U, so to speak. Represents a randomly selected student is female and participates in the after-school athletics program. So if you ever see A and B, that's how it's read. A and B. Okay, so if it looks like the U, that's the or, and the upside down part is the and. So we're going to write out a few sentences. So let me just remind you, A represented a student is female, and B represented they participate in the after-school athletics program. So based on the descriptions above, describe the following events in words. So if they say not A or not B, what they're basically saying is the randomly selected student, so the student is not female, or, watch that word or, does not participate in the after-school athletics program. Part B, A and not B. So this time, if I am A, I'm just saying a female student, well, a student is female, and does not participate. So not B does not participate in the after-school athletics. Okay, so I'll just review this table. Please don't copy it down again. You already have it in your notes. So based on the following descriptions in Table 1, determine the probability of each of the following events. So let me just remind you that A represents your female and B represents you participate in after-school activities. So I just want the probability of A. So the probability I'm female would be 580. There's a total of 580 females out of 1,000. And remember, you can represent this as a fraction, decimal, or percent. B, the probability that we are B, which participates in after-school activities. So if I participate in after-school activities, that's 400 out of 4,000. 400 out of 1,000. Now C says the probability you are not A. So the probability you are not female. Well, the only option here is if you're not female, then you are male. So I would say that represents 420 out of 1,000. Not B. So if B represents you participate in after-school activities, not B would represent you do not participate in after-school activities. So I would say that was 600 out of 1,000. Okay, so now we could be A or B. So that means you could be female. So you could be 232 if you participate, or 348 if you do not participate. So 232 plus 348 plus, now you could also participate in after-school activities. So we already counted the 232, but we'll also have to add on the 168. So did that go too fast on where those came from? I could be female, so I added anybody in the female row. Okay, or I could be in an after-school activity, so I added anybody in this row. Now I already used 232, so I didn't use it twice. So I'm just adding those three numbers together. So that got me a total of 748 out of 1,000. Now the probability that you're A and B. So you have to be female and you have to participate in after-school activities. So I have to be in the female row and the after-school activity row. So I would say that's 232 out of 1,000. Now the big idea of tonight's video is something called conditional probability. And here's the definition. The probability of one event occurring changes depending on other events occurring. So you'll notice I have the same table. So all you need is the questions here. A, what is the probability that if a randomly selected student is female, she participates in the after-school program? So conditional is kind of like the way it sounds. There's a condition that has to happen. So I always like to start by saying, what is the probability and what's the given condition? So the given condition, I'm just going to abbreviate there. What is given? The student has to be female. And the probability, what are we looking for to happen? What is the probability that if she's female, then she participates in the after-school program? So the probability, so we usually just do P and then what word it is, the probability that we're in the after-school athletics program. So my given condition is female and the probability is being in the after-school athletics program. So here's how I attack this one. I start with my given condition. So my given condition is the female row. This is the only row you can look at. I'm going to box it in. Okay, so my probability has to be out of this row. So my probability has to be out of 580 because that is my total. That's my given. Now in that row, I'm looking for the probability that you're in an after-school program. So now in this row, the probability that you're in after school is 232. Okay, so that's what a conditional probability is. What is the probability given a certain circumstance? So I was given I had to be female, so I could only be in this row. Now the probability I'm in an after-school program. So B, same table again. What is the probability that if a randomly selected student is female, she does not participate in the after-school athletics program? So we're going to write out these givens, the given condition and the probability every time here. So the given condition is that you have to be a female student. So my given condition is that I'm female. Now I want the probability that I do not participate in the after-school program. Okay, so again, start with the given condition. So that's telling you you have to look on the female row only. That means the probability total is going to be out of 580. Now looking only in that row, you want to be not in an after-school program. So now I would say that's a total of 348. Let's try C. A student selected at random is male. What is the probability this student participates in after-school activities? Okay, so what's given? The given condition is that you had to be a male student. The probability they're asking about is that you participate in after-school activities. Okay, so again, start with the given condition. That's where you're looking. The given condition is that you're male, so you are going strictly to the male row. Everything's got to be in this row. So my total is 420. So there's my total probability. And now I'm looking to find the probability you're in after school. So I'm only looking in this row, and the probability that I'm in after school is 168. All right, we've got one more. Now you notice they don't call it conditional probability. You have to be smart enough to say there's a condition. There's something that has to hold in this problem. Part D, a student selected at random is female. what is the probability that this student participates in after-school activities? Well, son of a gun, I realize that's the same question as part A, so I'm just going to actually cross that off, and I'm going to stick one more question in here that we really need to tackle. So let's call this E. A randomly selected student participates in after-school activities. What is the probability that she is female? Okay, so now what's given? The given condition is that you have to participate in after-school activities. Now the probability is that you are female. So again, you're starting with the given condition. You have to be in after-school activities. So let me scroll back to my table. So this time I have to be in after-school activities, which means my total probability, so I'm only in this column, my total in this column is 400. So I know my probability is out of 400. So now the question is, what is the probability you are female? So out of this column, the probability I'm female is 232 out of the 400. So our last question here says, describe two conditional probabilities that can be determined from the following row in table 1. Okay, so the given is going to be wherever that total is, remember. Do you know the total of the participating in after school, not participating, or male? So since I know the total male, I know I have to be given a student is male. So given a student is male, there's my condition. Given the student is male, now I could ask two different questions. What is the probability? I'm going to break it up into two questions. One, that they participate in after-school athletics. Or two, given a student is male, what is the probability that they do not participate in after-school athletics? Okay, so our last example here deals with a two-way frequency table on concession stand sales. So why again is it called a two-way frequency table? Well, remember, we have frequencies going in two ways. We have the rows being added up to a total, and then we have the columns being added up to a total. Hence, two ways, two-way frequency table. So the first question says, what is the probability a student bought water given they purchased a hot dog? So notice it's a conditional probability when we have this given. So my given condition, what had to happen? Well, I had to have bought a hot dog. And now the probability is that I purchased water. Okay, so given I bought a hot dog, what's the probability I purchased water? Once you have that, I think it's pretty easy. You're basically going to your given row. My given condition is that I have a hot dog. So that means my total, because it says total here, is 158. So there's my out of 158. And now I'm looking in that row, what is the probability I bought water? And that looks like 62 out of 158. Next question, given a student bought water, what is the probability they purchased a hot dog? Well, do we think they're going to be the same thing? Let's find out. So my given condition, what did I have to have happen? I had to have bought water. Now the probability is then you then got a hot dog. Okay, so again, start with the given. You're given that you bought water, so go to your water column in this case. So now everything has to happen in here. So the total of that given column is 140, and I want the probability that I bought a hot dog, so that is 62 out of 140. Now clearly those aren't going to be the same thing, even though the numerators are the same, the denominators are not. Well, I think that does it for us tonight, and I think if you just identify the given condition, that makes this probability fairly decent. So we look forward to some great practice. We'll see you tomorrow.